Welcome back, guys. I'm going to take up the last session of pair of straight lines. Before I start with the problems or the sums, let us first do a concept, a very small concept. This is called the general second degree equation in x and y. Now please understand that previously we have been dealing with lines passing through the origin. What if we have to find the joint equation of two lines which are not necessarily passing through the origin? Say for example we have two lines a1x plus b1y plus c equal to 0 and another line a2x plus b2y plus c2 equal to 0. Obviously these two lines are not passing through the origin, they have a constant present in the equation. So when we combine those two lines, these two lines, and when we multiply these two, on simplification you will get an equation in this format. This format is what? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This equation or such an equation is referred to as a general second degree equation in x and y. What is the difference between this equation and a homogeneous equation of second degree in x and y? The homogeneous equation of second degree in x and y just has these three terms. It doesn't have these next three terms. A homogeneous second degree equation would have every term having power 2, right? 2, 1 plus 1, 2, and this is again 2. Whereas a general second degree equation in x and y would have the highest power as 2, but then it would also contain terms which have a lower power or a term which doesn't have a power at all, which has power 0. Okay, so the joint equation or the combined equation of any two lines generally not necessarily passing through the origin, when you combine them you would get a general equation of second degree in x and y, not a homogeneous equation of second degree in x and y. Okay, now please understand that every general second degree equation in x and y does not necessarily represent a pair of lines. There is a condition. What is the condition? That this equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of lines. You have a determinant, and this determinant, if this determinant comes equal to 0, only then will this equation represent a pair of lines. Please understand that if this determinant comes equal to 0, will then this equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represent a pair of lines. Okay, now how do you remember this determinant? It's very easy to remember it. You just write a, b and c in the descending order on the diagonal, a, b, c, and then you just follow your alphabetical order a, b, c, and then you don't have a d or a e in this, you directly skip to f. So you write two f's on either side of the diagonal. After f comes g, then you write two g's over here, and then you write your h, one h here and one h over here. You can also remember this formula, abc plus 2fgh minus af square minus bg square minus ch square equal to 0. Even if this comes equal to 0, abc plus 2fgh minus af square minus bg square minus ch square, if this comes equal to 0, even then you can say that this equation represents a pair of lines. The better one is of course the determinant. Also, the angle between the pair of lines represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is given by that same formula that we learnt earlier, tan theta equal to 2 root h square minus ab upon a plus b. The conditions for parallel and perpendicular lines are follows. Lines would be parallel if h square minus ab is equal to 0 for obvious reasons. Lines will be perpendicular if a plus b equal to 0 for obvious reasons. We've already discussed this in the third theorem. Only difference is that here lines may be parallel or coincident. In the earlier case, the lines were coincident. They couldn't be parallel because both lines in earlier case were passing through the origin. Here there is no compulsion. So the lines may be parallel, the lines may be coincident. Also, what would be the point of intersection of such two lines which are represented by this second degree equation in x and y? The coordinates of the point of intersection are bg minus hf upon h square minus ab, comma af minus hg upon h square minus ab. So this is slightly a complicated formula, but nevertheless you have to learn it. In case of the homogeneous equation of second degree in x and y, meaning the lines, the pair of lines passing through the origin, there the point of intersection is obviously the origin. So you don't have a formula like this. This is only specific to any two lines, not necessarily passing through the origin. And so these are obviously related with your general second degree equation in x and y. That's just about the concept that we have to learn for us to begin the sums now. Now these are the sums based on the concepts that we just learned, or some formulas or concepts that we've learned earlier as well. So let's look at the first question. The first question, let's read it out. Find the joint equation of a pair of lines through 2 comma minus 3 and parallel to x square plus xy minus y square equal to 0. So what we do here is we compare x square plus xy minus y square equal to 0 with your homogeneous equation of second degree in x and y, which is what, ax square plus 2hxy plus by square equal to 0. So you get a as 1, 2h as 1 and b as minus 1. Very clear cut. A would be 1, 2h would be 1 and b would be minus 1. Then we also assume m1 and m2 be the slopes of these pair of lines, x square plus xy minus y square equal to 0. From that we'll get m1 plus m2, and m1 into m2 we've already learned the formulas for that earlier, right? Okay, so minus 2h by b would be minus 1 by minus 1, so that would be 1, and a by b would be 1 divided by minus 1, which would be minus 1. Now remember, the slopes of your required lines will also be m1 and m2 because your required lines are parallel to the given lines, right? It's quite clear here. Yeah, parallel to this, right? Your required lines are parallel to these lines, so obviously even their slopes will be m1 and m2. Also they are passing through the point 2 comma minus 3, so we can find their separate equations by the slope point form. What's the slope point form? It will be y plus 3 is equal to m1 into x minus 2. You remember this is y minus y1 equal to m1 into x minus x1, and the other line would be y plus 3 equal to m2 into x minus 2. Now we just rearrange the terms. So m1 into x minus 2 and this y plus 3 entirely I have taken there is equal to 0, and then I have this m2 into x minus 2 minus y plus 3 equal to 0, and then we combine these two equations because that's what we have to find, the joint equation of the two lines. And so let's combine them. So when we multiply these two, when we multiply this equation with this equation, you would get m1 into m2 into x minus 2 whole squared, and then you would get this term multiplied with this, so you would get x minus 2 into y plus 3 into m1 with a minus sign, and then you would also get a m2 into x minus 2 into y plus 3 with a minus sign. So I've taken that minus sign common, I've taken x minus 2 into y plus 3 common, and so I get m1 plus m2 in the bracket, plus the last term would be minus y plus 3 into minus y plus 3, which would give you a plus y plus 3 whole squared. Now we just have to substitute m1 into m2. We found m1 into m2 here as minus 1 and m1 plus m2 as plus 1. We just substitute them here and here, and so that's what I've done here in this next step. And then we just open this out, multiply this, open this out, simplify, and on simplification you'll get x square plus xy minus y square minus x minus 8y minus 11 equal to 0 as your required joint equation. Let's move to the next question. Now in the next question, let's read it. Show that this equation 2x square minus xy minus 3y square minus 6x plus 19y minus 20 equal to 0 represents a pair of lines. Also, find the acute angle between them. So there are two questions. We have to first of all show that this equation represents a pair of lines. Remember, I told you that any general equation of second degree in x and y will not necessarily represent a pair of lines. It has to satisfy a condition. So let's see if we can satisfy that condition. What is that condition? This determinant has to come equal to 0. So let's first take your equation and compare it with your second degree equation in x and y. From the comparison, it's quite clear that a is 2, then your b is minus 3, right? Then your c is minus 20. That's what I've written here. Your 2h will be minus 1, yeah. 2g will be minus 6 and 2f will be 19. And obviously therefore h is minus half, g is minus 3 and f is 19 by 2. So we have now considered this determinant ABC, 2f's, 2g's and 2h's written here, and now we are going to just substitute the relevant values picked up from here in place of A, B, C, F, G and H all over. I have to just solve this determinant. I solve this determinant, so it's 2 multiplied by 60 minus 361 by 4, 19 square, remember, is 361. Then minus of minus half becomes plus half, minus 20 into minus half becomes 10, and then minus of minus 57 by 2, so that becomes plus 57 by 2, minus 3 into minus 19 by 4, minus 9. We simplify this, take LCM, we do not cancel the 4 with anything, just keep 4 everywhere. Just take LCM. So that's 240 minus 361, that is minus 121 by 4. Then that's 20 plus 57, 77 by 4. 2 into 2 become 4. This 2 is not yet been multiplied inside, right? And then we also take the LCM here. You get minus 19 minus 36, which becomes and then you multiply the minus 3, minus 55 gets multiplied with this minus 3 becomes plus 165. The whole is divided by 4. This 2 gets multiplied, becomes minus 242, 77 and 165 would become 242, and so minus 242 plus 242 would cancel off and give you a 0. So since now that you've got a 0, the determinant has come equal to 0, it means that the given equation represents a pair of lines. Then they've also asked you to find the acute angle between the two lines. So we again take the same formula, tan theta equal to 2 root h square minus ab upon a plus b. I don't think I need to explain this again, because we've already done some similar sums in the earlier video. So you could just watch this. You've just substituted h, the value of h as minus half over here. A and b we've picked up, all these values have been picked up from here. A and b and h have been picked up from here, and they've just substituted in the formula, and I have just simplified it, and I get a tan theta equal to 5 in the end, yeah, and that would mean theta becomes tan inverse of 5. It's a very simple calculation. You can obviously do it on your own, but I'll just hold the video still for some time. Okay, moving on. Now let's read the third question. Find the separate equations of the lines represented by, you have 10 into x plus 1 whole squared plus x plus 1 into y minus 2 minus 3 into y minus 2 whole squared. So there is a pattern to this equation, right? So what we do is we just first of all just call this small x plus 1 as a capital X and the small y minus 2 as capital Y, and so the equation would become 10 into this capital X square plus capital X into capital Y minus 3 into capital Y whole squared. Now that is a quadratic equation which I think can be factorized. 10 into minus 3 is minus 30, so you're looking at a product of minus 30 and a sum of plus 1, so obviously minus 5 into plus 6 helps us, right? And so we just break this plus xy as minus 5xy plus 6xy, then we take 5x common between these two, you get 2x minus y. You take 3y common here, you get 2x minus y. So you get 2x minus y common and you get 5x plus 3y in the other bracket, and that would mean the separate equations are 2x minus y equal to 0 and 5x plus 3y equal to 0. Obviously these are the variables that we have introduced, so we have to go back to the original variables. So capital X would become small x plus 1, capital Y would become y minus 2. Likewise over here we simplify and we get the separate equations as 2x minus y. You see this plus 2 minus of minus 2, that's 2 plus 2, that becomes 4. Even here 5x plus 3y, you have a 5 minus 6 which becomes minus 1. So 5x plus 3y minus 1 equal to 0. Let's come to the next question. Question number 4. Find P and Q if the equation px square minus 8xy plus 3y square plus 14x plus 2y plus q equal to 0 represents a pair of perpendicular lines. Perpendicular lines, remember, pair of perpendicular lines. So we are again comparing this equation with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, and we get the values of a as p, right, b as 3, right, and then c comes equal to q. Then you have your 2h being minus 8, you have 2g being 14, and you have 2f being 2, and like therefore we get h as minus 4, g as 7, and f as 1. Now since the equation represents a pair of perpendicular lines, you know that a plus b is got to be 0, because if lines are perpendicular then a plus b has to be 0. If a plus b is equal to 0, we just pick up the values of a and b, insert them here, and from here you get the value of p as minus 3. Then since it is also representing a pair of lines, you know that this determinant is got to be 0. So we assume the determinant to be 0, we pick up these values and insert them at the relevant places. We solve for q, and once we solve it we just get an equation in q, and that would give you q as minus 8. I'll just hold the video for a couple of seconds so that you can just go through the determinant evaluation. Alright, moving on. Now this is an important question, and this is the last of the questions. So let's read this question very carefully. Triangle OAB is formed by the lines x square minus 4xy plus y square equal to 0 and the line AB. The equation of the line AB is 2x plus 3y minus 1 equal to 0. We have to find the equation of the median of the triangle drawn from the origin. So I'm drawing my y-axis and my x-axis. This is the x-axis, this is the y-axis, and this is the origin. So there are two lines. You can see OA and OB are two lines passing through the origin, which are being represented by x square minus 4xy plus y square equal to 0. And then there is this line AB, which is represented by 2x plus 3y minus 1 equal to 0. We are interested in, and so obviously OAB is a triangle, so we are interested in finding the equation of the median OD. Okay, now what does a median do? A median would obviously what is a median? A median is a segment drawn from the vertex of a triangle to the midpoint of the opposite side. So obviously this D has to be the midpoint of AB. So if A and B coordinates are x1, y1 and x2, y2 respectively, then obviously your D would be x1 plus x2 upon 2, y1 plus y2 upon 2 by midpoint formula, right? Now, therefore, what we need to do is we need to get A, the coordinates of A, and the coordinates of B. Because if you have the coordinates of A and B, then obviously you can find the coordinates of D. And once you know the coordinates of D, you can find the slope of OD, and then you can obviously find the equation of OD. Remember, OD, because O is the origin, it's a line passing through the origin. So the equation of a line passing through the origin will be y equal to mx. So if you just get the m, which is the slope of OD, you can get the equation of OD in no time. So how do we go about finding the coordinates of points A and B? Remember, they are the points of intersection of the equation x square minus 4xy plus y square equal to 0 and the line 2x plus 3y minus 1 equal to 0. So we can solve this equation with this equation simultaneously and get these points of intersection. So let's do that. Let's solve them simultaneously. So what we do is we take x is equal to 1 minus 3y upon 2. How do I get that? Remember that 2x plus 3y minus 1 is equal to 0. So x is 1 minus 3y upon 2. That's exactly what I've done. And I will insert this in x square minus 4xy plus y square equal to 0. Wherever I have x, I will substitute 1 minus 3y upon 2. That's precisely what I've done here. In place of x, I've got this. In place of x, I've written this. Y as it is, y square as it is. Simplified this. It's a very simple simplification. I'll just hold the video for your reference. After simplification, we get this equation 37y square minus 14y plus 1 equal to 0. You get a quadratic in y. So let us assume y1 and y2 be the roots. Yeah, y1 and y2 be the roots of this quadratic equation in y. And what are these y1 and y2? They are basically your y coordinates of points A and B. So obviously this quadratic equation is unsolvable, so at least we can find y1 plus y2, which is the sum of the slopes, the sum of the sum of the roots. So y1 plus y2 is minus b by a, minus b by a. y1 plus y2 is minus b by a. This is done in class 10. Alpha plus beta is minus b by a. So alpha is y1, beta is y2. y1 plus y2 is minus b by a. So that will be minus of minus 14 upon 37. So that's 14 by 37. Now what do we do with that? Remember, the y coordinate of D is y1 plus y2 upon 2. So why don't we just take this y1 plus y2 value and divide it by 2. So y1 plus y2 upon 2 would become 14 upon 37 divided by 2, which would become 7 by 37. So obviously D ka y coordinate is now 7 by 37. And you also know that D lies on AB. Yeah, your D lies on AB. So obviously D will satisfy the equation of AB. What is the equation of AB? 2x plus 3y minus 1 equal to 0, which is also x is equal to 1 minus 3y upon 2. So I substitute the value of y in that, right? I simplify and I get 8 upon 37. When I get 8 upon 37, it means I've got the coordinates of D as 8 by 37, comma 7 by 37. Once I know the coordinates of D, I get the slope of the median OD, yeah, by y2 minus y1 upon x2 minus x1, right? And that is how I get 7 by 8. Remember, this is the origin. So OD, D coordinate minus O coordinates, right? 7 by 8. So the slope of median OD is now 7 by 8, and therefore the equation of median OD would be y equal to mx. So y is equal to 7 by 8 into x. That is 7x minus 8y equal to 0. And that's how you do this sum. I hope you have followed all the sums that I have covered in this video. This is the end of the chapter. I will see you again with a new chapter very shortly. Thank you so much for watching.